Okay, so we are going to do number, let's see, let's change a couple things. Change that. We'll write in black so we can see it, make it a little thicker. Okay, so let's do, what did I say we were going to do? 16 and 17 and 20. Okay, so let's do 16 right now. Or I'm sorry, we're doing 17 first. Because 17 is a horizontal and vertical line. It's a little bit easier, I think. All right, so we'll do that one first, kind of work our way up to the ones that might be a little bit tougher, okay? Is that fair? Yes, Mr. Hammer, very fair. Thank you so much. Okay. All right, there's this. Let's make that a little bit thicker. Yeah. There was a commercial years ago. Did I tell you that? Yeah. Was it thick? Yeah, was it peanut butter? I can't even remember. Ask some old person that's my age that watched TV back then, and they'll tell you. It's thicker. I remember that. All right, so let's do this. So 17. What do we got? The line is -2, 1, -2, 1, and 4, 1. So if you graph that line, graph those 2 points, connect the 2 dots together, connect the 2 points, you'll get a line, right? And it says we want to find the distance from this point, 5, 7. So the point, I'll put P for point, is at 5, 7. So here's our line. This right here is our line. Okay? So let's put this in a different color, make it kind of darker. -2, 1. So -2, 1 is right here. And 4, 1, 1, 2, 3, 4, 1 is right here. So what kind of line do we have? It's a horizontal line, isn't it? Alright, just goes like this. Make that a little bit thicker. There we go. Alright, so there's a nice horizontal line. And we have a point 5, 7. So let's figure out where 5, 7 is. Do I have enough room to get to 7? So 5, 7. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Way up here. Just made it. Would you agree? Alright, let's do this in a different color. Let's do it in red. And so what are we trying to do? Trying to find the distance from this point right here, right? This red point to this purple line. That's what we're trying to find. So what is that distance? That distance is from here straight down, right? Or perpendicular, right? That's the word that we use, to there. You could go all the way through if you wanted to, but I don't.
How come you don't draw it
This way?
Yeah.
Because what is the distance from a point to a line? It's the perpendicular distance. That was the whole key of yesterday. That was like the most important part of yesterday, wasn't it? That the distance from a point to a line is the perpendicular distance. So this is perpendicular. If this is horizontal, then this has to be what? If the purple one is horizontal, then the distance has to be vertical. Got it. Okay. So really, all we got to do is find that distance from here to here. So what can you do? Just count. Yeah, just count. Right? That's easy, isn't it? I don't have to do any of that stuff we did yesterday on this problem. All I got to do is count. 1, 2, 3, 4, 5, 6. Boom, there it is. So that distance right there is 6. Yep. What do you mean, why did I tell you? I told you everything you needed to know yesterday, okay? You're just going by blind, okay, do this step, do this step, do this step. What you have to do is you have to have an understanding. Just wait a minute. You have to have an understanding of what you're being asked. Okay, you're being asked to find the distance from a point to a line. Well, here's the line right here. Here's the point right here. The distance is the perpendicular distance, right? So I draw a perpendicular line from this point to this line. So even though we didn't do exactly that yesterday, you should have been able to look at it and say, okay, this is what I'm trying to do. I graph the line, put the point, now I got to find the distance from that point to that line. And then if you look at it, you probably were amazed. You probably look at this problem and said, oh, wait a minute, that's kind of easy. All I got to do is just find the distance of that red line. All I got to do is just count it, right? You could go through all those steps that we did yesterday with finding the equation of both of them and all that kind of stuff. But on this one, you didn't have to do that. Without graph paper, you mean? Or without graphing at all? You might have not realized. If you didn't graph it, you may not have actually realized that this was a horizontal line. All right? The key to tell you it was a horizontal line was that these two numbers were exactly the same. You went up exactly on the y on this point as you did on this point. So the y points are exactly the same. That means the only thing changed was the x, right? So it had to be a horizontal line. I would graph them, okay? Every one of these I would graph if I were you. Did you really absolutely need graph paper? Not necessarily, because where was this line right here? This was at 1 on the y-axis, wasn't it? Right? That was at 1. Where was this point? This was 5, 7, so that was at 7. How far is it from 7 to 1? It's 6, isn't it? All right, so you could have done it like that. Brooke?
So like, can you do that for any problem or no?
Well, only if it's horizontal and vertical where it's that easy, okay? Because all you got to do is count over. Now, on the other problem, which one was it? Was it 18? 18. On on the other problem that was like this. Okay, 18, it started off with a vertical line and you had some point over here. So what do you have to do? You just have to count across horizontally. So 18 was kind of like this. All right?
18, I got like a line like this and then like that.
On 18, yeah, you graphed it wrong because it's 4, -1 and 4, 9. So your x stayed the same. All right? You went from -1 to +9 on the y-axis.
If you had like 18 except the vertical line was moved over this way, would be like -3.
Now you wouldn't have a negative anything. You'll never get a negative for a distance, okay? Because remember the distance formula, it was under a square root and you squared two things. When you square both things, no matter if what's inside there is negative, you're going to get a positive number. You add them up, take the square root. So you'll always get a positive answer for your distance, okay? All right, let's do 16 now. You okay with that? All right, let me grab my little x and y axis dealy thing. All right. And let's, come on, where is it? Oops. Daggone it. Come on, grab onto it. There it is. Where does it look like it's kind of, is it right there? Is that good?
Yeah.
Okay. Alright, so there's my x and y axis again. And let's write some stuff down. And we're doing 16 this time, right? Ooh, 11, it figures. I don't have that much room. Let's do another one besides 16.
18.
Let's just do 15. Alright? They're small numbers. They're relatively small numbers. 16, the numbers are too big for my graph, so I'm just going to do 15. Let's do 15 instead. Everybody got 15?
That was in the back of the book how to do it.
They showed you how to do it in the back of the book.
Alright, we'll look in the back of the book then. Alright, we'll do 17. I'll stretch this thing out. I mean, what am I doing? 16. Okay, we'll do 16. Alright, we'll do 16. I'm so confused. Alright, we'll do number 16. Everybody okay with that? So let's see what I got to do. I got to go 11 over and 11 down. So let's see where I can put this.
Do you have to graph all of them?
It'd be a lot easier, to tell you the truth. Maybe like that. How's that? Do I have 11 yet? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, perfect. And then that looks like plenty of room. Okay. So let's put it on here. It's 11, -1. Ooh, that's a little too thick. There we go. 11, -1. That's 1 point. And then -3, -11. -3, -11. All right. And point P is at -1, 1. All right. So let's go blue this time. Nah, we got these blue lines. Let's go
Do pink.
pink.
Yeah.
That right there? Is
Yeah,
that
that's
pink?
all.
Okay. Alright, I just did. 11, -1. So that's 11, right? -1 is right here. And then -3, -11. So -3, 1, 2, 3, -11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, man. Let's move this up. Then I'm going to have to move this point up, right? Yeah. See, I can't do that on a whiteboard, could I?
It'll be a mess.
So what is it? -3, right? -1, 2, 3, 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Way down here. And if you really wanted to, if that bugs you, we can just scooch that line down a little bit. All right, what are we going to do with that? Those 2 points make a what? A line. Connect them, right. That's exactly what we're going to do. So let's connect them. So let's connect from here to here. All right, and let's make it purple or pink, whatever that color is. All right, so there's our line, and then let's put the other point, -1, 1. Let's make this green. Green and purple. How's that? Like Barney. All right, negative
I thought it was pink.
-1, -1, 1, right there. So now, what are we trying to do? We are trying to find, that's point P, right? We are trying to find the distance from this point to this line. All right, that's why I think the picture is very helpful to us, because it lets us visualize what's actually going on. So I got to draw a line from here to here, but I got to draw it how? Do I draw it to the ends? No, draw it perpendicular. So we'll just eyeball it. Where do you think perpendicular is? Up? Maybe right there? Okay. Now, it might be there, but what we're going to do is we're going to guarantee that it's there. Okay? You could take an educated guess, and we used graph paper and everything, didn't we? Okay, so you could use a nice educated guess to find out where that point actually is. Or, we don't know where that point is right now, do we? So if I don't know where that point is, let's call it XY.
If you graphed it on paper and you just found out what the point was on paper, you just use that and do the distance.
I mean, if you got it right. Okay, we were fairly accurate on this, but who knows? I might have guessed it down here or up here, and sometimes it may not be right on a point. Okay, it might be like halfway or a third or something like that. So you can't. Now, my guess is that it probably is that point right there. Okay, but you can't always just assume that it is. Okay, because we didn't measure out perpendicular and all that kind of stuff. We just kind of eyeballed it, and it kind of looks like it should be there, doesn't it? Okay.
So you don't go straight down.
You don't go straight down. You go perpendicular to the line. All right. You don't just go straight up and down vertical. It's perpendicular to this line. It's got to make a right angle. That was an ugly right angle. Okay. It has to make a right angle to that line. Okay. Yes. Dominique, just you're trying to get out of it. Okay. You're trying to get out of doing some work. Let's not try to get out of it. Because it's not always. Listen to me, please. You've got to understand, they rig these things sometimes in the book, all right? Sometimes it's going to be ugly. Sometimes it'll be ugly numbers and it won't come out like you think it should. No matter if you measure it or not, sometimes your measurements aren't correct, all right? So don't just measure it. That's not what we're trying to teach you. I'm trying to show you how to find this point and how to find this distance, right? That was the whole idea, wasn't it? To find this distance. That's what we're trying to do. But in order to find this distance, what do I need? I already have a point right here. What else do I need? I need a point right here, don't I? And so my whole deal is to find this point. Let's go back to the purple one. And what we're going to do, our very first step after graphing it all, our very first step after that is to find the equation of this purple line. So let's find the equation of this purple line. And how can we do that? Well, how did we get that purple line? We got it from these 2 points right here, didn't we? All right, this is old stuff. This is stuff that you should be able to do fairly easy. So let's find the equation to this line. First thing we're going to do, let's do the work over here, is we're going to find the slope. Let's find the slope of the line. So it's the change in y over the change in x. So it's -1 minus -11. That's the change in y. Then the change in x is 11 minus, what? -3. So that's a plus. So what do we get? We can slide it in here. That's a 10 over what? 14. Let's reduce that. That's what? 5 over 7. So the slope of this line right here, the slope of that line is 5 over 7. Thinking ahead, we're not going to do it right now, but thinking ahead, what's the slope of this green line going to be without doing any other work? -7/5. Exactly right. Okay, I was just thinking ahead. We're going to do that in a little bit. So now I found the slope of this purple line. Now what I need to do is find the y-intercept of this purple line. So I'm going to throw it into this little formula right here. What do I know already? I know the slope, don't I? Which is 5/7. What else do I know? I know an x and a y, don't I? From either one of these points. It doesn't matter which one you use. Which one would you rather use? Let's go 11, -1, okay? So that means the y is -1. What's the x? It's 11. So I'm going to put this 11 over 1. Now this is going to come out a little bit ugly.
Can we do decimals?
Nope, no decimals. Use fractions. Use fractions. So watch. Negative 1 equals. Now what do we get here? That was a positive 5/7. That's 55/7, right? I'm going to go a little quick, but I am recording this, so you can go back and look at the arithmetic. Alright? So now I'm going to subtract a 55/7. Let's rewrite this. I don't want this negative 1. Let's write this negative 7 over 7. Why would I do that? So I could subtract 55/7 from it, right? So subtract 55/7, and what is b? It's negative what? 62/7, isn't it? Now look at this. 62/7 is kind of close to negative 9, isn't it? Because 63/7 would be... Now look at this. I did this on graph paper. See how it didn't hit exactly at negative 9? Some of you might have looked at it and said, well, I use graph paper. It looks like it's pretty close to negative 9. The y-intercept is negative 9. But is it? No, it's not. It's close to it, real close to it. But it's negative 62/7. It's close to negative 9, but just a little bit above it. And that kind of shows from my graph. So that's the y-intercept. So what's the equation of this nice purple line right here? Y equals what? 5/7 x, what? Minus 62/7. What do I do with that equation? Put it in a box for safekeeping. Okay? We're going to come back to it in just a few minutes. Let's go to the green line now. Green one's actually a little easier because we already found one thing. What did we just find? We just found the slope, didn't we? So I know the slope of that green line. So the green line is what? Negative 7/5. How did I get that? Because the slope of the purple one is 5/7. They're perpendicular, so this is the negative reciprocal. So it's negative 7/5. Now what do I have to do? Find the equation. mx plus b. Okay? I only have one point to choose from, don't I? On the purple one, I could have chosen from either one of these, and I still would have got the same exact y-intercept. On this one, I only have one point to choose from because I only know one point that's actually on that green line. So I'm going to put those points in there. So y is what? It's positive 1 equals m, which is negative 7/5 times x, which is negative 1. X is negative 1, isn't it? Plus b.
You have to put in point P.
Yeah, because you have to put the point in that lies on that line. Okay, you can't put a point that doesn't lie on the line or it won't work. You can only pick a point that lies on the line. That's what that x and y represent. That x and y represents any point on that green line. I only know one of them, right? I could kind of maybe guess at maybe some of these others, but I wouldn't want to guess. I wouldn't have any clue. So that's what I do. So what's this? This is positive 7/5, right? So I'm going to write 5 as 5/5. This is positive 7/5, so what do I do to that? I subtract a 7/5. So what's b equal to? Negative 2/5. So look at this. It looks like it's halfway, doesn't it? But 2/5 is like 4/10, right? It's close to halfway, but not exactly half. Everybody see that? I would have never been able to just look at the graph and just guess negative 2/5, would you? No. So that's why we have to put the numbers in. Miriam. Yeah. Right here? Yes. Because, well, it was a negative 1, but see, since this was negative and this was negative, it was negative times a negative, I made them plus. So originally it was a negative because of the... Yeah. Originally it was a negative 1 because of this, but then I made it a plus because it's a negative 7/5 times a negative 1, so I made them both plus. I know, I understand. I'm just explaining. I understand. Okay? So there we go. Now, we did all that work to get those two equations. Why do we care about those two equations? Because what we're trying to do is this. We're trying to find the point that's in common with these two lines, aren't we? So I want to find the same x and y that work for the purple line that work for the green line. All right, so what am I going to do? This is equal to y, this is equal to y, so what do I do with those two things?
Well, they're equal to each other.
Right.
But why is isn't the same way? It's like you get the same answer as the different, but why is it different if they do it?
Because they do it wrong, I do it right. I don't know. if you really look, I haven't even looked to see how the book does it. Tell you the truth, I really don't even.
They like line it up and add it together.
Yeah,
so
it's the same thing. I like my way.
it's what-
Yep, I definitely like my way better now that you said that. Yes.
When you do the negative reciprocal, so if you got the slope was 3, would the slope for the other one be like negative
1/3. Yep. 1 over
1/3.
3. 1/3. Yep. Exactly
I'm
right.
doing this all wrong.
Okay. So now, what are we gonna do? Now, the book does. They might do something a little different. They might substitute and put them on top of each other and all that kind of stuff. But this is what I do. Since this is equal to y and this is equal to y, they're equal to each other, right? So let's set them equal to each other. So negative 7/5 or x. I'm sorry. Let's try that again. Negative 7/5 x minus 2/5 equals this thing right here, right? 5/7 x minus 62/7. Now we just solve for x. And you're like, yeah, right, just solve for x. Okay. But watch what we do. Plus 7/5 x plus 7/5 x. What do we have to do here? We've got to find a what? Common denominator. Well, these cancel right here. Okay, yeah, what's your common denominator? It's 35, isn't it? All right, so that went to 35. This went to 35. So what'd you do to 5 to get to 35? Multiplied it by what? By 7. So what's this going to be? If you multiply this by 5, I'm sorry. If you multiply 7 times 5 is 35, right? So 5 times 5 is 25. Plus 5 times what? 7. And 7 times 7 is 49. Right? Just common denominators, all I'm doing. You did that back in 4th and 5th grade, didn't you? Adding with common denominators? Yeah. Okay. So what is that? 74. So it's 74 over 35 what? X. Okay, so I've got that on the right side, don't I? Let's move this 62 over 7 over. This is good practice with everybody's favorite fractions. No. These are exact numbers. Decimals are going to give you approximations. Okay, we don't want approximations. We want exact numbers. So look what we get here. Common denominator again is 35, isn't it? Okay, 5 times 7, so negative 2 times 7 is negative 14. See how easy that is? It's not hard. 7 times what? 5, right? It's 35. Somebody do this for me. 62 times 5, 310. Okay. All right. This is positive because this is a plus. Okay. So what do we got here? We got over 35. And what's this? 2 what? 296. Okay, good. So now look what I have. Looks a little ugly, but now it's going to be kind of nice because how do we get rid of that fraction? Multiply by the reciprocal, right? And look what happens. We get this.
The JV and varsity
So look.
field hockey team and the JV and
Look,
varsity
this is just a
soccer
simple
team are now
algebra 1
met.
step, okay? You guys are getting all worked up. We're almost finished. Just give it a minute. They'll wait for you. Okay, look. So look, somebody do this on the calculator. What's 296 divided by 74? Somebody do that. Quick, quick, quick. Come on, calculator. Who's got a calculator?
4.
It's 4? Exactly 4. So x is equal to 4. Very good. So that's 1/2 of our point. Now we have to find y. So I could use either one of these. Let's use this one right here. So y equals 5/7 x, which is 4, minus 62/7. So what do we have here? We got 20 over 7 minus 62, which is what? Minus, did that work right? Did I do that right? 5/7 x, 20 over 7, minus, minus 62/7. 62, that's 42, negative 4. Yeah, that's right. It's negative 42. Did I say that? Negative 42 over 7, which is what? Negative 6. So look at that point right there. That point right there is what? 4, negative 6. That point right there is 4, negative 6. All right? So y is negative 6. Wait a minute. Just wait. So it's 4, negative 6 right here. I know. So I got these 2 points right here. You could have just counted, couldn't you? 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. It fell exactly where it was, right? But sometimes you got to understand, they all left, and I told them to stick around. We're almost done. They're not going to leave. They weren't going to leave you, I promise. They would not leave all those people. It's so important. Just okay. I know it's recording. It's not always going to come out perfectly on a dot right there. Okay? It's not always going to do that. Sometimes it could be in between somewhere. I really wanted to go through all this because I told you right at the beginning, didn't I? That it probably will come out right there. All right? But I wanted to show you for sure that it came out right there. Now, it probably won't get any more difficult than this with all these fractions and all that kind of stuff. Okay? But now we still have one more step to do, but now it's an easy step. What's the easy step now? The distance formula. So let's do this in red. So what are our 2 points? -1, 1, and 4, -6. So it's -1, 1, and what? 4, -6. So all the work was really to find that, wasn't it? That was all our work. Okay, the distance part of it was actually kind of easy. The hard part was finding out that point. Once we found that point, now we can do the distance formula. And that's the easy part. So just a little distance formula action right here. Subtract the x's, -1 minus 4. Subtract the y's, 1 minus -6. That's -5 squared is 25. And this is 7 squared, which is what? 49. And you do that with that 6, that's a 74, right? Square root, and that's your answer, isn't it? Looks familiar? I think I read that off, didn't I? Yeah. So what is the distance of that little that green line right there? It's the square root of 74. Now look, I promise you, if you can get what we just did right there, you can do any of those problems. I don't think any of the other ones are any more difficult than what this one was. Yes. Yes. All right. Now look, it's recorded. I made sure I recorded it because I knew there was a lot of tiny little details in there. There are a lot of little tiny details. But the overall problem, how many steps did we say that problem had yesterday? Didn't we say 5? Let's count the 5 steps, okay? What color do we write the 5 steps in? I've used all the colors. Yellow doesn't show up too well. Let's use this blue right here, okay? So what are the 5 steps? I think the first step would be to what? To graph the thing, right? So we'll call that 1 step. What's the second step we had to do? Find the equation of the lines, okay? So find the equation of the lines, right? Lines, how many lines? 2 of them, right? Now that was a little bit of work, but we found the equations of the lines, all right? We'll call that 1 step, even though, yeah, it's basically 1 step. All right, so what's the second thing we did? After we found the equation of the lines, here's one, what did we do to them? We solved for x and y, didn't we? Okay, so you set them equal to each other, didn't you? All right, so let's say set equal, right? And that wasn't hard. Set equal and then do what? Solve. We'll put this all in one step. Set them equal and then solve for x and y. That was our third step. After we solved for x and y, that gave us our point, didn't it? So after we got our point, look, I'm streamlining this. It's only 4 steps now. All right, so what's our last thing? Find the distance, right? So do the distance what? Formula. All right? So if you look at it, break it down into those steps. You graph it. That's kind of obvious. Find the equation of the 2 lines. That really wasn't all that bad. Sometimes, though, if it comes out as ugly fractions, it's a little bit tedious. And I would agree with you. It was just a little bit tedious finding the, with all those fractions. But it's stuff that you've done before. Okay, you guys have to know how to work with fractions. It's very important that you do that. All right. So now, once you actually get the equations of the lines, you set them equal to each other. Do a little bit more math. It's just, again, basic Algebra 1 math. Solve for x and solve for y. All right. I consider that 1 step. And then once I get x and y, that's my point. That was the key right there, to find that point of intersection between the 2 lines. Once you find that point, then you can take the 2 points, this one and this one, find the distance between them, and then that was like the easiest part of the whole problem, wasn't it? Doing the distance formula. Okay, all the rest was a lot more work. The distance formula was a piece of cake after you got done all that stuff. All right, and then there you go. Yes.
If like X or Y came out to be like 4.5 or 4 point something or a fraction,
Right.
we round that to the closest one.
Where are you going to use fractions? You're not going to round anything. We're using fractions. We're not using decimals. Okay. Do not use decimals on these things.
Like if it was like a 4.6.
It's not going to. It won't come out as 4.6. It's going to come out as a decimal. I mean, it's going to come out as a fraction. I want you to use fractions. Okay. When you do all this stuff and you do all this math, it's going to come out as a fraction. Don't put it as a decimal. I don't know how else to say that. All right. Don't use decimals. Use fractions, because fractions will come out to exact numbers. Sometimes decimals will not come out to an exact number. Thus, you have to round. You ever have to round a fraction? No, you never round a fraction. You round decimals. You round decimals because fractions are already exact numbers. 1/3 is an exact number. Listen to me. 1/3 is an exact number. 0.333333 repeating is not an exact number. I could sit here all day, my whole life, all of eternity, and keep going 33333, right? And it won't be exact. But 1/3 is an exact number. You follow me on that? Okay? So I want you to use fractions. I know. It is easier to use a decimal. Why is it easier to use decimals? Well, because you got calculators and everything else. And you can even do fractions on a calculator. But you got to learn, okay? You got to learn how to work with fractions. Look, you did this stuff back in 4th grade, didn't you? This stuff right here. Well, it takes too long. So what, okay? You're doing it right, though, okay? You're doing it right. That's what you should care about. Look at this. This is what everybody's griping about right there. It's just adding a couple fractions together with an uncommon denominator. All right? Telling you what, though, when you get into Algebra 2, because I've seen where you're going to go. I've been there, okay? People look at this and say, oh, I'll just do that on my calculator. Or I'll change it to a fraction. Or change it to a decimal or that kind of stuff and round it. No, 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 no. Because in Algebra 2, you know what you're going to have to be adding? You won't add something simple. You would wish for the days you would have to add 5/7 and 7/5. You know what you're going to be adding together? You're going to be adding together stuff like this, like x squared over x to the 3rd plus 5, plus, I don't know, it's not even 5. I'm just making these things up. But you're going to have crazy things like that where they're going to almost all be letters and all be crazy things, and you're going to have to actually add things together and find common denominators that you can't do on a calculator, that you can't turn into a decimal and round it. You're going to have to learn how to do this stuff. You will be thanking me, all right? You'll be thanking me that you were forced to add fractions together, because you're going to need to know how to do that when you get to Algebra 2. I promise you, all right? Because I've taught it for many, many, many years. I've taught Algebra 2. I'm not this year, but many years I've taught it, and you're going to wish that you remembered how to add fractions together. And this is good practice for you. Okay, enough of that. It took 30 minutes just to go over one or two problems, okay? So, tell you what we're going to do. You hang on to that, and the ones that you still couldn't get, the ones you didn't get before you came in today, go through this whole thing again, try it, try to get the right answers, try to understand what you did. Look, we already went over 3 of them, right? And I only gave you, 5 of them to do, 6 of them to do, okay? And I doubt they're all going to be this crazy with these ugly fractions. I kind of doubt they'll all be like that.
All
right.
left for sports.